Hi folks, and welcome to another video about fans and physics. Now, as I said in my previous video, I'm going to be talking a little bit about the electronics of fans and how they work, but I'm not going to go into too much detail because I'm aware that for some people it's just not very interesting. But I do want to talk about this because it will become relevant, as you will see later on in this video. Now, the first thing that I want to draw attention to is this matter of cogging that we saw in the end of the last video, where if you push on a fan blade very gently and keep pushing, it will eventually spring, like it did there. It will spring to the next position, and this is because the rotor is magnetized in 4 different places. So each time you push it, I'll do that with the other hand so you can see it more clearly. Each time you push it round, it will cog. It will get stuck. Now, what we can tell from this, without even disassembling the fan, is that it has a 4-pole magnet on it, and that tells us a little bit about the motor. So let's have a look at the motor. Now, I did already disassemble this fan, and because of how fans are constructed, this part of the motor, which is called the stator, this is permanently mated to the frame. And that's because if that wasn't the case, that's an awful lot of torque. The impeller and the rest of this assembly would just fly off. Here's a little bit of a closer view at the stator. Now, what appear to be 4 windings or 4 separate masses of copper wire are in fact all one length of copper wire. The copper wire is wound in such a way that there are 2 pairs of magnetic poles when current flows through this. Now, being a single length of copper wire, this is what's called a single phase brushless motor. We'll get into that a little bit more later in the video, but for now, this is your basic fan motor that is featured in probably 99.9% of all of the fans in the world. It's a very simple design, it's very cheap to manufacture, and it's also relatively maintenance free and should run for a long time without problems. Let's have a look at the PCB round the back of this stator. Okay, so here's a nice zoomed in close-up of the reverse side of this printed circuit board. Now, it might appear intimidating at first, and I want you not to worry about any of that because we're not going to talk about the design of the electronics themselves. I just want to identify a couple of things about this. First thing that may appear obvious, and I'll explain, half of this PCB on the right hand side here has got no components on it. And that is because there are certain functionalities have been omitted from this fan to cut down on manufacturing costs. This fan being a 2-wire fan, you can see at the bottom here, only the positive and ground are connected. There are 2 pads. One of them will be for the tachometer output, and the 4th is for the PWM input for the speed control. This PCB, when it's fully populated, will support all of these functions. And the way that it does that is via the use of this here, which is microcontroller unit. Now, in different fans, this will look different, but the fundamentals of a PWM fan are pretty much the same. Every PWM fan will have a similar design to this. It will have quite basic circuitry, and it will have a control chip that handles the PWM signal that tells the fan what speed to operate at. Now, I'm going to flip it over, and I'm going to show you one more thing from the other side. Right, so the last thing really to talk about is this little component here that is labelled H1. That is a Hall effect sensor. The Hall effect sensor, in simple terms, tells the control chip around the back of the fan where the rotor is. And you could say also that because of the Hall effect sensor, the control chip knows how fast the rotor is spinning. And in a PWM fan like this, that's really important because then it will know what to do when it receives the different signal. Now, simpler fans will not have a control chip. They will have transistors that do the switching, and that will mean that the speed is fixed, and the only way that you can change the speed of the fan is to change the supply voltage. Now, let's have a look at another fan that is slightly more impressive than this. I have here one of my Sanaces, which I decided to paint purple, and I'm actually not quite sure why, but regardless, the fan still works very well. And what I've done is I've removed the clip at the back, which will allow me to remove this rotor, but the magnetic force is extremely strong on this one, so it's difficult to take apart. Give me just a moment. Give it a good tug there. Now, first thing, look at the size of that bearing. It is absolutely enormous. The next thing, that's a lot of copper wire, and those are a lot of coils. Now, this is a very powerful fan that we're dealing with, and this uses not a single phase motor, but a 3-phase motor, and there are 12 windings on this motor, and of course that means also that there will be 12 corresponding poles on the magnetic ring inside the impeller. Now, first thing that I want to draw attention to here, just really briefly, I'll annotate this on the video, there are 3 Hall effect sensors, and that's because each phase requires its own Hall effect sensor. Now, here's a question. If a fan like this uses a 3-phase motor, why don't all PC fans use 3-phase motors? And the simple answer to that is 3-phase motors are really not necessary at all for simple operation in one direction. There are some advantages to 3-phase motors. They can be a lot more powerful, which means they deliver more torque. They can also be a lot more efficient. And the biggest advantage of 3-phase motors is that they offer much higher resolution speed control than single-phase motors. Now, let's have a wee look at the Phanteks T30, which also has a 3-phase motor, and I want to point out something that that fan does, which is quite interesting. So here's the really interesting behaviour from the T30. What I want you to do is watch the display on the tachometer when I power this fan up. Now, before I do that, I'm going to remind you that this fan has a maximum operating speed of 3000 RPM. That is per the spec sheet. Most fans have a plus or minus 10% kind of variance, which allows the motors not to be quite so accurate. Watch what happens here. Right, now I'll put that off. You see for yourself, so that is quite an incredible level of speed control accuracy. And because of the quality of the motor, it is able to do almost exactly 3000 RPM consistently. Now that's just the tip of the iceberg, because another thing is fans tend to slow down when they meet resistance. And I'll be interested to see whether or not the T30 is adversely affected by high levels of static pressure. Now we'll cover that maybe in another video, but for the moment I think that you have a kind of an overview of the 2 main types of motor. You've got single phase and 3-phase motors, and by and large single phase motors are adequate for PC fans. When it comes to 3-phase motors, they offer a lot of advantages that are not really useful when it comes to this application, but it's still nice to see this level of refinement in products in this market. Thank you for watching, and I'll see you in the next one.